Okay, so we looked at the sorry, jumping a bit ahead. We were looking at first at how we could do, if we jump back even more, see if we have that here, looking at how we could do kind of analysis block by block, right? To see what is the average values by block with standard deviation. And then we looked at how to use rolling averages, remember, to check how does this evolve over time, so kind of more trends over time. Another thing we can look at is when values are outside the normal range for an individual, and this is called like, then you would use something that is called a set score or scaled variable. So let's do that. Sorry. Call it scale, or we can actually call it normalization is normally called, so, or a Z score. And what we're interested here is, so we have these different variables that are on different scales, right? So if we look at the daily data, we have, for example, if we remember, our SRSS score was between 0 and 24. And in the same time, our resting DFA alpha 1 is somewhere around 1, maybe. So these are on really, really different scales. And to know, for example, what is outside the normal range, it gets harder. A normal way to work with this is to normalize or scale a variable. And what that is to subtract the mean. So we're going to go step by step here. We're going to take the daily data, and now we're going to do we're going to just select our we can take the we take those two. We take the SRSS recovery and we take our daily we take our rest DFA alpha 1. So if we look at these two, again, you see that they are on really different scales here, these two. And if we now summarize these, so let's do the SRSS recovery mean. And our SRSS recovery standard deviation. And now we do the same for, now we do the same for our resting DFA alpha 1. You will see here, our SRSS recovery has a mean of 16 and a standard deviation of 2. And our DFA alpha 1 has a average of 0.9 and a standard deviation of 0.28, more or less. To normalize these ones, what we will do here is we're going to mutate, and so we're going to say we have a SRSS recovery that is centered. If we start with this, so this is the first step. We want to center our variables, and the way of doing this is by taking the value and subtract the mean of that value. So if we do this, we can do it for both at the same time actually. And then we start by looking at the values. Now you'll see here that we have this is the original scale, and now you'll see that these SRS's recovery centered, they're gonna be, in this case, 19 minus 16 with some rounding is more or less 3, right? So here you see that these values now are just the same values as before, but with a mean of 0. So when we take out the mean, we create mean 0, and we can actually double check this to be certain. So if we take the mean and standard deviation, and now instead of the here we have our raw versions, and here right now we have our centered versions. Okay, so here we're gonna take, instead of the raw versions, we want our centered. Let's see. Take out the view. We run this, and now you will see. Now we start to get so wide that we need to do this way. So now you will see here that the raw ones are the same, but the centered version is. You see here that this is the like scientific annotation, because when you work with computers, you don't work with exact values. There is some rounding error, but we see that this is 0 down to the 15th decimal, right? So if we would take these ones and round to, let's say, 5 decimals, and this one also, we round to the 5th decimal and run, you will see here that now the mean value here is something wrong. Let's take a look at that. No, is supposed to be 0. This one worked good, the SRS's recovery centered. This one is not correct, so good. Let's go back and see where we did. See here, we subtracted the SRS's recovery, not the mean of the. So we subtract the mean. Now we run it, and we see that now the mean of our scaled centered variables is 0. Good. Next step then is to get to do the same, because we see that the standard deviation of the SRSS recovery is around 2, and for the DFA alpha 1 is about 0.2. So to get these ones on the same scale also, what we do is we take all this and we divide by the standard deviation of the value of the variable. And then we do the same here. We divide by the standard deviation of the resting DFA alpha 1. And we just put them on separate lines, so it's a little bit easier to read, to see all. Actually, no, we skip that. So now you see here, now these ones are not centered anymore. Now they are scaled, or we normally call this Z values. So all these centered ones, we're going to rename just to be correct. These ones are now Z scores, or scaled scores. So when we look at this now, you will see that the mean is 0 and the standard deviation is 1. So this is what a scaled or a Z score version of a variable is. And this helps us put them, because if we now would take here, for example, we're gonna do it another way, but so this is just to show you that these ones are this is a good way of seeing how much a certain value varies from the standard, the normal for an individual, and it allows us to compare between all the different variables even when they are on different scales. So an option here, so this was to show you how this is done. There is actually a function for this which is called scale. So then we could just take our SRSS recovery, use the scale function, and here you see you have center, which is centering, taking out the mean value, and scale, which is dividing by the standard deviation. So we could actually just do scale and run this, and you will see that we get the same kind of results here. Now, probably what we are interested in currently, at least, is to plot these ones, for example, to see which ones are outside the normal range. So again, to plot several variables in ggplot, we want to work with the long format. Remember that we have each variable for each day on a separate row. So what we are going to do is we're going to pivot longer first, the ones we're interested in. Pivot longer, same as before, we have in this case SRSS recovery, and we have our rest DFA alpha 1. We want to call names to variable. We could actually, just to make it so we look at this just to make sure that it's correct. Here we have SRS's recovery and the rest DFA alpha 1, and we have our raw values for now. Remember that they are not scaled, but what we can do when we have it in this long format is we group by variable, and now we can use the so we want the value to be the scaled version of the value, so we just update this. And we look at how that looks, and now you will see that we have values that are more or less centered around 1 and go up and down 1. Like we could actually now, if we want, just to make sure that it works, summarize, and now we want the mean of the value, and we want the standard deviation of the value. And we see that the mean is basically 0 for both of these, and the standard deviation is basically 1. So now we are working with both of them on the same scale. We can call this data rest. We could actually data long rest, because it's resting type of variables, for example, and then sed to have the set score. Now what we can do here is we can take this. We're gonna do one more thing actually. When we have this, we could create a column to see if this is how much outside the normal they are. So what we could do here is then we could call SD category, and we're gonna do we're actually not going to use case when. We're going to use, I think we're going to try to use the recode values. So recode values is what this one does is another one. We've used case when before, but recode values, what we say is we take a vector, so we take the value vector, and now we're gonna say when let's see if we have a good example here. No, I think we actually don't have. So when this value is so we look here from to okay, we're actually sorry, we're not gonna get it, we're not gonna do too advanced stuff. If you're interested, look more into recode values and so forth. But what we can do here is if we want to make it a little bit easy for ourselves, let's mark all the variables that are outside 2 standard deviations, right? So we're going to call them like outliers. So when the absolute value of the value, so absolute is just either we take out the minus sign. So we say that when the value is either above 2 or below -2. So I hope you work with absolute values. It's just taking out the minus sign. So outlier is is the absolute value larger than 2. So we run this, and now we can look at our column here in the end. Now we'll see it's false for most, but here we have a couple of values that are true, right? This day, the 28th and 29th of May, we see values that are outside the normal range, and this could be a good way first to look at like which are the values, because now we could, for example, take this one and say filter outlier, and when we have true and false, this is basically just saying give me all where this is true. Okay, here we get a problem. We could say when outlier is equal to true. Let's see if, no, that doesn't work either. Let's see what the problem is here then. So we look at our data long rest set, and we look at our okay, so here we see that this is some special kind of column. What happens with this, the reason why it's like this, is because if we take this out and we run only with the rest set, you see that the value column now has some weird extra information to it. That comes from using the scale, because what it actually does is that it saves the mean and standard deviation. So we're gonna go back and we're gonna do this by hand. So we're just gonna take the value, we're gonna subtract the mean of the value, and then we're going to divide by the standard deviation of the value. And remember, since we do by group by, it does this for each variable. Remove the missing values. Now you will see that the let's see here. Now you'll see that the value is a normal column here. So if we now try to do like outlier, and then we check if the absolute value is larger than 2, we save this, and now I think this one is gonna be normal. We're gonna check, and now this works. And you see here that we have 3 days where we have these values that are bigger than 2 standard deviations. Again, if you want, another option here is to do standard deviation category, and we could then use, for example, the case when, just to and say when the absolute value of the value column is smaller or equal to 1 standard deviation, then we could call this category, for example, smaller than 1 SD. We could even do this, and then we say when it's smaller or equal to 2, it's within 2 standard deviations, and if it's larger than 2, then it's larger than 2 standard deviations. We run this, and now we can see, if we look at that one, that we have these different categories of the variable. And the nice thing with this is what we can do with this, and again, as you see here, there are several different ways we work with this. I'm trying to show you a couple of different ones. Choose one that works for what you want to show in your plots. But now if we take this one and we do ggplot, our x-axis is going to be date as normal, our y-axis is going to be value, and actually maybe it should be value said, right? Our standardized, just to show that we are standardizing, and then we are working with a standardized version all over here. And then we do points, and then remember we need to do, for example, facet wrap by variable. And we have a look at this, and again, here you see that we have our 2 variables, and if you compare this, if we do the raw value instead and run this, you will see that we have very different scales on them. But what happened is we don't actually change the how. If you were look at this pattern in SRS's recovery, you will see that the pattern looks the same. The only thing that changes is the scale. But now we have these 2 on same kind of scale. And then what we could do here, for example, now would be to say we color by the standard deviation category. Sorry, and we use the Z score. So now you would get like, these are the within the normal range, these are between 1 and 2 standard deviations off, and these are the outliers. And maybe a better way in this case to compare, to see them, it wouldn't be next to each other but maybe above each other. So then we could do facet grid, and then we could say row, our rows is based on our variable. This way we'll get them on top of each other, and now it's easier here to check, for example, okay, here we have, this is an outlier, And if we look, we see the same day the SRS's recovery is also an outlier. One is high and one is low. So then this is an easier way to kind of see a little bit what happens on the same day for a variable. So this you could do. This you could do with more. Also, you could do it with several variables. But this is a way to kind of look at which are days that are outliers for, and it's easier also to then get the same scale for all the variables. So that is normalizing or scaling.